So welcome back, grade 10s. We are now going to talk about kinetic energy, B2.3 in your textbook. So potential energy we just discussed, that's stored energy. Kinetic energy now, just as the name implies, has to do with motion. So kinetic energy is the energy due to motion. The energy due to motion. So as long as an object is moving, it will have energy. So the symbol now for kinetic energy is a capital E for the energy, and then we're going to do a subscript K. So now we know we're talking about kinetic energy. We are still dealing with energy, so the unit will be a joule. And the formula now, which is on your data sheet, just like the potential energy formula is on your data sheet, has to deal with kinetic energy. So you will see it written as EK equals 1/2 times the mass of the object times the velocity of that object squared. So you will see it written like this, or we can kind of simplify it a bit, and we can write kinetic energy is the mass times the speed squared, all divided by 2. So some students like to write it like this just because it kind of shows that when you multiply by 1/2, you're just dividing by 2. Okay, so we are now going to go into our workbooks, and we're going to take a look at workbook page B41. I'm going to go through three different examples with you, so just kind of showing how to manipulate the equations. And then when we finish that, there's some workbook pages and some check and reflect questions that you guys can work on to practice. Okay, so here we've got the formula up here, EK equals 1/2 mv squared. Just remember, you can also write it EK equals m times v squared, all divided by 2. Either formula works. Okay, so let's take a look at example number 1. So again, we're going to write down what we know, and then we're going to figure out what we have to solve for, write the formula, and then manipulate it if we have to. So a 0.3 kilogram ball is pushed horizontally at a speed of 20 meters per second. Calculate the kinetic energy of the ball at the moment it starts to move. So the mass of the ball is 0.3 kilograms. The speed of the ball at the moment we push it is 20 meters per second. We want to solve for the kinetic energy. So the formula for kinetic energy equals 1/2 times the mass times v squared. We're going to just plug in our values, and again, we have to make sure that our units are right. So mass is kilograms, and our speed will always have to be in meters per second. So just remember, v, speed, has to be meters per second. Okay, so 1/2 times 0.3 times 20 squared. So if you do want to use your calculator function with the fraction, you could write it in as EK equals 0.3 times 20 squared all over 2. And when you plug that into your calculator, you should get 60.0 joules. And we're going to go to 3 significant digits because we have 3 here and 3 here. So your final answer would be the kinetic energy of the ball is 60.0 joules. And when we talk about energy, we're talking about a scalar quantity, so there is no direction. Okay, let's try another one. The kinetic energy of an object moving at a speed of 14.2 meters per second was determined to be 950 joules. What is the mass of the object? Okay, so let's write down what we know. The speed is 14.2 meters per second. The kinetic energy is 950 joules. They are asking to solve for the mass of the object. So this is one of the equations where we're going to start with our base equation. So EK equals 1/2 times the mass times v squared. And we are trying to solve for mass, so that's what we're going to isolate. So in order to solve for mass, we've got to first, well, we can do one of two things. I'm going to multiply by 2 first, because if I take 1/2 and I multiply by 2, I'm going to get 1. So do the same thing to the other side, multiply by 2. Then I'm going to divide by v squared to move the v squared over. So now on the right, the v squares are going to cancel to 1. And then when I have my equation, it is now mass equals 2 times the kinetic energy, all divided by the speed squared. So we can write that in. 2 times 950, all divided by 14.2 squared. What do you get for an answer? And you should get 9.42 2 kilograms. And then for our final answer, we're again going around to those 3 digits. So the mass of our object that's moving is 9.42 kilograms. Okay. The next example here, number 3. We now want to solve for the speed of an 800 kilogram automobile if it has the kinetic energy of 9 times 10 to the 4 joules. So let's write it down. The mass is 800 kilograms. The kinetic energy is 9 times 10 to the 4 joules. We want to solve for speed. Okay, so first step, we're going to write EK equals 1/2 m times v squared. So the first thing we want to do is we have to move the m and the 2. So I'm going to divide by m, and I'm going to multiply by 2. So now if we just take a look at what's left, I have v squared is equal to 2 times EK over my mass. I don't want to solve for v squared, so I have to take the square root of my v squared, and that'll get rid of the v squared, so it becomes v. But I have to do the same thing to the other side. So now the equation is 2 times EK all over the mass, and then we take the square root. Okay, so let's plug in our numbers. This will be 2 times 9 times 10 to the 4, all divided by 800. And again, you should always be taking a look to make sure that your units are adding up, or that are the same. And so for this one, you should get 15. And the units are meters per second. If we go back and look at significant digits, I've got 3 and 3. So my speed is going to be 15 decimal 0. That makes it 3 digits, meters per second. Okay, so that's our kinetic energy. We're going to end here for today. So what you should be doing is finishing up any of those problems that we were doing in potential energy, and then you're going to do workbook page 42, and there's some practice problems at the bottom of it. I will be posting what your homework is on D2L, so just make sure you double check what's there. Have a great one.